Good morning, one and all. Today I am discussing about applied geotechnical engineering 18 CV6 to 6 semester module 1 lecture series 9. Today we are discussing about drainage and dewatering methods, estimation of groundwater table by Huspalis method. What is meant by dewatering? Whenever we are doing some construction activity, so if a water is encountered, it becomes very difficult for excavation purpose, difficult for laying PCC, difficult for laying mat, for foundation construction, etc. So at any point of time, our construction site below the ground level, so up to the depth where we are doing foundation construction, it should be free from groundwater. Therefore, what we are doing is we are reducing the water table level beyond our working place. So how? By removing the pumping out of that water. So now with that introduction I can say dewatering means dewatering is required for any deep excavation to facilitate construction of basement, powerhouse, pumping stations and so on. So all these things comes below the ground level. So you might have observed that is last 2-3 months back. So in North India, so there is a ice that is collapse that has entered into the powerhouse constructing tunnels and where a lot of catastrophic failure has taken place. So this is an example where the powerhouses etc. will be constructed below the ground level and sometimes below the water table level. So we should ensure that water table at any point of time will not be higher than the base of the tunnel or base of our excavation. So theoretically, any excavation below groundwater table could necessitate some kind of dewatering. Low permeable soil does not require dewatering because permeability is low, means that is, for example, clay, then flowing of water towards construction site is very less, whereas medium soil requires some type of dewatering technique. The basic purpose of dewatering is to control seepage into the excavation either by pumping the water out of the excavation or by lowering the water table sufficiently below the bottom of the cut till the underground water works. Now various methods are used for dewatering. There are some of them ditches and sumps, well point system, shallow well point system, deep well point system, vacuum method, electrical osmosis method. What I mean to say here is each method cannot be used for all the type of soil. It is each soil will have its own way of removing the allowing the water to pass through them. Depending on their ability of water to pass through them, we have to use some method to quickly water that particular area from water table effect. So first one you can see here the ditches and sumps. We have taken this photo from this courtesy website. So here in ditches and sumps, what we are doing is we are making a borehole, we are making a submersible pump or hose pipe we are fixing, and we are continuously pumping the water from the ditch or sump so that water table is reduced to our requirement. But this is limited to some extent. Beyond that, caving in of soil will take place. So generally discriminated depth is used for this particular technique. Coming to the second one, single stage well point system. Suppose here if you want to lower the water at a one stretch well point system, what we are doing is we are fixing a what is called as a that header pipe, and header pipe is connected by a flexible swivel connector, and internal it is connected by a well point riser technique, and water is allowed to drop from these pipes to, and it is moved to the header pipe. Thereby it is go to the duty and standby pumps, and from that it is V-notch or wear from the water, it will be taken out to a safer place. So that earlier water table was here, because of infusion of these well points and this header pipe, so the water table has reduced. With one that is a layer of this header pipe, we are reducing the water table to a shallow depth, is called a single stage well point system. Coming to a deep well point system, whenever the water is to be removed at a deeper depth, for example 16 meter depth, then that is a borehole will be done, and a perforated pipe will be placed here at this particular point, that is from here to here, and surrounding to that a graded gravel will be filled, so that the because of the higher permeable graded gravel compared to surrounding soil, water starts moves here and it start collecting in this sump portion. A submergible pump will be fixed here. Automatically it will be pumped off to a safer place. Thereby water table is reduced. This is called deep well point system. And suppose if a excavation is to be done for deeper depth and water table is to be reduced to a deeper depth, in a single well point system cannot possible to do. We have to go from top to bottom stage by stage. Here some slope we have to maintain, header pipe we have to fix, and well points we have to make, and we have to lower the water table to this depth. Again excavate to the next layer, fix the header pipe and the well point, lower to the water to the next layer. Likewise we have to move it by stage, therefore it is called multi-stage well point system. The problem here is when we adopt this multi-stage well point system, so entire ground get disturbed because of this stage by stage excavation. Therefore generally this method is avoided in most of the cases. Next is vacuum method of dewatering system. So whenever the fine grained soils are there, then permeability rate is very less. In case of fine grained soil, it is in the order of 10 to the power of -3 to 10 to the power of -5 centimeter per second. There naturally allowing natural giving a time to flow the water is not possible, or water cannot possible to reach this place. In such a case, what we are doing is we are making a borehole and we are fixing a that is a header pipe and is connected to a multi-stage pump, the dual pump. Initially this pump will act as a vacuum pump, and the sealer will be provided, the bentonite clay here top, so that no vacuum will move here. It has to move through this pipe only, and by using this vacuum pump, a vacuum will be created by sucking the air inside this borehole. When air is sucked inside this borehole, water starts moving from surrounding to this borehole. As the water started collected in this borehole, this vacuum pump will automatically convert it into a submergible pump, and it starts driving the water from this particular tube, and thereby water table is reduced. So this is called vacuum method, is only used in fine grained clayey soil. Next is electro-osmosis method. So this electro-osmosis method is also used in foreign countries to lower the groundwater table. Suppose this is the place where the construction site is there. This is the groundwater table and it has to be reduced. So what they are doing is, on the upstream end of this construction site, a series of pumps will be fixed. The boreholes will be done. Casings will act as a pump, and it is connected to the pump. Lower end, the sheet pile walls will be constructed, fixed, and sheet pile walls will act as an anode, and the pump will act as a cathode, and a potential electric current will be connected between anode to cathode at a minimum of 40 volts, and because of the potential difference, then there is a flow of water takes place into this pump, from which water will be boiled out, and the row of cathodes will flow take place. Flow will changes in reverse direction because of electric current interference, and thereby groundwater table is reduced. This electro-osmosis method works on the principle of osmotic pressure, and this method is used in foreign country, and because in India it is less popular, the reason is it required a huge electricity, and therefore it is highly expensive in terms of cost. So this is about electro-osmosis method. Coming to the objective type questions related to today's discussion, dewatering is required for any deep excavation to facilitate construction of basement, powerhouse, pumping station, etc. So on. Whether this statement is true or not is the question. Answer is true. A. Theoretically, any excavation below ground water table should necessarily some kind of dewatering. Option is A. Low permeable soil does not require dewatering. So yes, it is true. A medium soil, specifically special type of dewatering required. Yes, it is true. Basic purpose of dewatering is to control the seepage into the excavation. Yes, it is true. Example of some method of dewatering is this stage? Yes, it is true. Multi-stage dewatering is required whenever the deep excavation below groundwater table is to be carried out. Yes, it is true, but not always correct. So again, with the available answer, we can say true. Vacuum method is useful for coarse grain soil. No, it is wrong. It is used for fine grain soil. So option is B, false. Vacuum method is useful for fine grain soil. For next question is true. Electro-osmosis method for borehole is acting at a negative electrode. Yes, it is true. So these are a list of references we are used for preparing this particular module. I take this opportunity to thank collegiate and technical education officers and the students for giving me an opportunity to deliver this particular lecture. Thank you, one and all.
PPT